Okay, yesterday the LEDs come in the mail, and so did the USB end I cut on the cord end, and they have the cord with the same USB mail in. I cut it off and just soldered header jumper wires, some female header jumper wires to it, a couple of them, so I could power it from that port there when I put it in the case. But I have to drill some screw holes for it to screw so it can hold the panel mount USB connector into the case. Anyway, you probably see over there the red light on the board of the Raspberry Pi is blinking. It's doing that because the voltage is going below 5 volts, 4.73 I think. Right now it's going to have a meter hooked up to it, and instead of right there, it's not that big of a difference on it, so it shouldn't harm it. You know what it must be is that it probably had it before, but the thing is, it probably wasn't close enough for it to go off, to turn off. Without the LEDs, because the LEDs on there, I measured them on my power supply I built, and they have come up to 3 milliamps, which that ain't very much, and it shouldn't harm the thing because it's 3 milliamps. These are LEDs that are meant for like 12 volt LEDs, but they'll work at lower voltage. As what they put on there is like, all it is a resistor for at 12 volt to make it be at the maximum current that it could possibly use without breaking, so it can achieve brightness. It can still achieve brightness at lower voltages, such as like 5, because all it is just a resistor that limits the current. It won't be the brightest as it would at 12, but that's okay. It looks pretty bright enough, as you can see there. The printer's on, you can see, and it works. I tested the Ethernet light, and it turns off when the Ethernet doesn't work. I believe the same thing goes with the wireless network. If it's having problems with the wireless network LED will turn off. And there's 5 LEDs there, and if you time that by the 3 milliamps, you'll get 15 milliamps. 5 times 3 is 15. Anyway, I can show you how it works. I'm first going to show you how I disconnect the phone, if I can. It's disconnected. 1 LED, 2 LED should go out. You just saw this. That one there is not lit no more. That one there. Then if I hook it back in, it should light up back up again. Let me know that those tether is working, and so is Internet, I mean. It took me a lot of time, especially the Ethernet one. Took me a lot of time because of the way of decoding it. Like for example, if the Ethernet was off, let's put this down. If the Ethernet was off, its IP address would still be there, and I noticed something that the pinging would still work. So I had to change it and to look up a file, the virtual file path in Raspbian that would
You got mail, bud? You want me to open it for you?
Not yet.
Are you on the phone?
I'm making a video. I hooked it back up, and you can see the lights turn back on.
I think it's electronic stuff.
and so when you hook it back up, the lights turn back on. Anyway, now it's blinking. You see that it's the voltage is not going that pretty low. Not unless it's oscillating. I hope it's not oscillating at a low voltage, which I don't think it would be. It hasn't turned. I've been running it for a while, and it has not had any problems. Act like that's not the problem. Like that problem's not even there. I mean, because everything looks like it's not even dropping the voltage. Anyway, I got the power USB charger from Walmart. It was like a 2.5 amp power supply, and if anything, if it does have problems, I could always use that other end I chopped off on it, off of this panel mount USB connector, because it had the same end as the input. The end on it is like the printer one, and I like that end. I like that I chose that end instead of micro USB, because micro USB is very brittle and it can break, and it's cheaply made. My last phone I used to have, the USB connector broke on it. We had a hard time charging. We prop it up some way because the pins were not making contact. Anyway, I can unhook the Ethernet one. Which one's the Ethernet one? Let's try that. I'll unhook the red wire from the router, and it should change one of the LEDs. I'll just unhook the power wire from the router, turn the router off. In a minute now, it should take effect. I think it just did. The red one. This red one here is LED for the router because there's a red one on top of this USB connector, and it's not even lit. As you can see there. I probably was lit before. Let's hook it back up and see. I wonder if I can hold it like that. There we go. And move it a little bit back. Trying to pop my camera up, get a good angle at it so you can see if it turns on. There you go. Now you can see it. I can easily look it up. Oh, come on. Let me see if I can reach it. It's in the hole. Uh-oh. Damn it. It's in. The red light should turn on any second now. Okay, it just turned on, as you can see there. And that shows you that the Ethernet light just works. The red light was not on it. The tablet fell too on it, and I was hoping that's not good because it could have shortened out the wires there. I'm supposed to get some electric tape soon. Well, I might get some from Jamie if we can't get anything, because he has electric tape at Futures. Because I don't want those wires in it to be touching. Because if it touches, it'll short out the wires. Especially since the power one's on it. This is not just your general input output pins or GPIO pins are being used that are uninsulated. It's also the power ones for it that power the Raspberry Pi. Well, that's it for now. I'm going to show you the schematic of how to build it yourself now. Thanks for watching. If you like it, and here's the schematic. Okay, here's the schematic of the router's LED panel. It only has a few, only like 5 LEDs. Yeah, 5 LEDs and 5 resistors. There's one LED that's common on it is ground, and the other 4 is commonly positive. This is because of the return value of ping command in various tools. Return of 0 for success and 1 for error. So it would use those to make up the bits of 1s and 0s. And that's how basically it would turn on an LED or not. The resistors are needed, and they usually are needed unless the LEDs you got, like the ones I have built-in resistors. To have built-in resistors, you can leave them out and hook it directly to the LED. But you do not. Well, if the LED you don't know about it, I would suggest putting a resistor in it, just in case if it shorts out. If it shorts out, it can break stuff, and it can break the LED, it can break the Raspberry Pi. So you make sure that you know that the ones I have, I know they are because of the ones that will put in cars without resistors. They're supposed to hook up directly to the car's power, but it works on 5 volts. It dims a little bit, but that's okay. It's bright enough. Anyway, the LEDs are prioritized. There's an anode, there's a cathode, so you have to make sure you hook them up correctly. And that's about it. You just mount that in case. You can probably even take the ones off the router's board. I was going to use one off of mine, except the one thing is that all of them had common. I could probably fix that with filing down the traces and then make a cut between the traces so that it doesn't flow to the side of the board. That would have worked, but that's okay. I like to have different colors for my LEDs instead of the same ones. I like that better. This will look nice too. Well, that's it for now. I hope you enjoyed this video. Thanks for watching. If you like it.